changing. On the right hand side, there are 3 pictures. Top ones are for 2 different levels of significance. One is for 5%, another one is 0.5% significance. We can see that the nature of the curves are almost similar. There is a drastic reduction in the t value as you increase the number of degrees of freedom from 1 to 2. From the table also you can conclude that. So this will give you an idea how many number of measurements one has to do so that you will get quality results. As you can see, if you increase the number of degrees of freedom, for that matter, the number of measurements beyond, say, 6, the gain or improvement is only marginal. So 6 is an almost practical number also to do replicate measurements to get quality results. From this nature of the curve also you can conclude. 7 replicates. Yes. When you say degrees of freedom, in this statistics, all the tables, it will be +1 will be the total number of measurements. 7 will be ideal, but even 6 also you can see almost. That is why there are 2 vertical lines given on the lower part, either for 4 and 6. 5 to 6 number of measurements will be sufficient, and it will also depend on the level of or the quantity which you are looking for. The absolute value of the quantity also will decide. If you have a larger quantity, for example, if you are looking for a chair in this room, it will be visible to you. But if you are looking for a needle in this big room, it will be difficult for you to do. You may have to search for more time, or you may have to do it some 2-3 times. Maybe first search you may miss it. Whereas the chair is visible. So like that, the quantity, the value of that particular parameter also will have a hold on how many measurements, number of measurements will give me a reliable result. That also we will see. Similar to Z table, we have done several exercises. Today we will try to utilize the T table and try to derive the confidence level, confidence interval. Confidence interval is nothing but the range or the base value of the Gaussian curve corresponding to x bar plus minus t singular value. If we are taking mean values, x bar plus minus ts by root n. Here in this one, a sample of water is analyzed for chlorohydrocarbons. We have been given several number of measurements, but not the mean values. Individual measurement values. For example, 17 ppb is reported by 5 people, 20 ppb is reported by 7 people. Like that, individual values are given. When we are taking individual values, confidence interval, we will use the equation x bar plus minus ts. Okay, that equation we will use. And the x bar we can calculate from the total number of measurements, 5 plus 7 plus 9 plus 8 plus 6 plus 6. That adds up to 45. There are 41, not 45. 41 measurement values are there. Then that you can calculate x bar. You can calculate S standard deviation also. Then you can calculate the t value. And one can compare this t value with the value in the table, which we call as the critical value. Similar to the Z table we have used. Let me show you the t table also alongside so that it will be easy for you to do. Since there are 41 measurements, the degrees of freedom will be 41 minus 1, 40. Then we have the calculated mean value as 17.7317. Then the t value you take from the table. 94-95% confidence level for 40 degrees of freedom. all of you could read the T table. Now, is it readable from you, from your place? No? It is readable, no? Already it is marked with an ellipse only, with a purple ellipse color, so that you can read it. And finally, when you get the confidence limits, then we apply the rule for significant figures, two significant figures for that uncertainty or the standard deviation. So the standard deviation comes out to be 4.0. And the average, now the average we will round up to first decimal as per the rule. 18.0 plus or minus 4.0. Do anybody need my help to read this table, T table? All of you are comfortable reading through it, na? Number of measurements you know, then one is subtract one corresponding to that and look at the requirement. If it is a certain percentage of confidence level will be mentioned, else the significance level. Confidence levels are mentioned. Look at the table on the downmost row. There it is written confidence levels. So for that corresponding confidence level, read the T value corresponding to certain degrees of freedom. Okay. Then X bar plus minus TS. Sir, yes. Here actually there is slight modification is required because in the denominator it is written n minus 1. We have to use n. Xi minus x bar, pardon, it is more than 30, na? More than 30. So the denominator will be slightly modified. Instead of 41 minus 1, it should be 41. We have kept to the rule because this rule was also like evolving. Earlier there were number like n up to 20. Some people were saying up to 30. Some people were using up to 50 also. So this reference is from that previous one. So you slightly modify. I will do the modification and send you. For the standard deviation calculation, denominator should be n because this is large enough number as far as the measurements are concerned. So there will be slight modification in the standard deviation, but it will not affect much rather. So from this we will be able to tell with certain level of confidence what will be the value of this total chlorohydrocarbons in a particular sample of water taken from a specific location. From 14 to 22 ppb, 14.0 to 22.0 ppb, it will be varying. So you will be able to tell with so much confidence with one significant figure after the decimal because your standard deviation is under that much control. So it is not only the measuring device, your ability to interpret the data accordingly. That will also add up to the quality or the a firmness of your data. Okay. We have understood the Z value, T value. Now we will try to understand whatever data is reported, whether it is reliable, whether the data is reliable or not, depending on the level of that parameter you are looking for. What are the things you have to stress upon so that your value is impressive, the value is better in quality compared to already existing values? That also can be defined in terms of these statistics. T statistics, the difference from the measured value and the true value that we call as deviation or delta is Ts by root n if we are taking the mean value. And there is one more term which is called the reliability interval, which will include a reference point of the whatever value or whatever the base value you are looking at. So it will be 100. It will be actually represented in the form of base. That means you will be multiplying that value with 100. with a baseline or the reference point as the actual value, x value, or the your value, whatever is the measured value. T value we know how to calculate and how to compare it with the T critical table that we have learned in the previous one also. Now, depending on the level of that parameter, how it is changing, how it is whether improving or decreasing the quality of the data, that is for like finally affirmed via this term called the reliability interval. Many of the times when you are developing a new method or whenever you are doing like a preparation of a new instrument, new equipment, what is the reliability of that equipment to do certain sort of analysis, certain level of analysis. This term will be written in the specification of those equipment or the methods if you are developing some new method. Since it is taken as a percentage, you can compare the performance of one particular equipment with that the other one because their bases are all same. When we are comparing the performances of two, their bases should be same. That is why this reliability interval is kept so that the normalization is taken. Once you do this numerical, you will get the feel of it. We have to find the number. From the T table, we have seen that beyond 6 or 7 number of measurements, we are not gaining much in terms of the quality of the data. But at the same time, you can see that if the level or the concentration or the parameter which we are looking for, the numerical value will also have some hold or say whether 6 number of measurements or 7 number of measurements are required or not. In this numerical, we have to calculate the reliability interval, which is nothing but 100 times delta divided by that value, x value. You have to calculate the reliability interval for 2% of that analyte, that element, chlorine, as well as 20% of chlorine at two different levels. And the standard deviations are also different, 0.051 and 0.093, almost double when the concentration is increased 10 times. The standard deviation, absolute standard deviation, you can like visualize that it will always increase with the numerical value, whereas relative ones will remain almost constant. And all are in percentage. Here also we can take help of the T table, calculate the T value, then we can go ahead with the reliability interval calculation. Pardon? Pardon? This one. See, we can calculate the T value and come to a conclusion. Whichever has got like a smaller value, we will say that it is better. Now the thing is that at two different concentration levels we are talking. So at lower level concentration, whether that much number of measurements will be sufficient enough to give me quality or data. For example, 20% is relatively higher concentration, higher level. 2% is lower level. So just by getting the T value, we will not be able to make a conclusion. For that, the furthermore, one more information is required, that is the reliability interval, wherein we normalize a value with respect to the actual value. For example, if it is for 2%, we take it normalized to for 2 value, then that particular value, then multiply with 100 so that the baselines are normalized. That is the thing. So 100 times delta. Delta is TS or TS by root n. Okay. Why so many chairs are vacant? No idea. So T value we can calculate for different degrees of freedom, say starting from 2, 3, 4. What is the number? First number? 1. 1, 2, 3, 4, 5. Up to 5 different degrees of freedom you can calculate. Say 1 degree of freedom, you can just try to do. For 1 degree of freedom, what will be the T value? It is 12.71, isn't it? And for the first part, the X bar is 2%, and T, for example, for 1 degree of freedom, it is 12.71. and the standard deviation is 0.051. Okay, and that will be T into S will be your confidence interval on either side, isn't it? Then you multiply with 100, divide by the two value, that actual value, that will be a reliability interval. Reliability interval. That is another term. Normalization procedure, because I am sitting at two different points. For example, if the second standard ka bacha or fifth standard ka bacha, if I am saying that the second standard child is better than the fifth standard child, what is my basis to compare? So I have to do normalization. Maybe you may have to like divide, or like you may have to take care of their age at least factor. For second standard child, his or her like level of thinking will be up to that age level, so age factor also you have to consider. That type of normalization is done in the case of reliability interval. Okay, in order to get a meaningful conclusion regarding different concentration level or different parameter level, whatever level. Since I am in chemistry, I have given a few examples related to chemistry. Whatever parameter you are looking for, let it be a larger value or smaller value. If you have to compare them, let the bases be normal, bases be say normalized, then compare. That is the only thing. In all these exercises, the idea is to convey how to read the T table, how to make meaningful conclusions, how to improve the quality in terms of precision and accuracy of your measurements. These are the like ultimate targets for us. After learning, after having attended these classes, you will be able to interpret also. Sometimes some table is given, some information table, result table is given. From that, you can make a judgment whether the data is reliable or not, whether this person has given the full like information, or whether he has not revealed the entire data. If the total number of significant figures are not expressed, that means that the entire data is not revealed. Sometimes extra information is given, whether that is required. And that will help me also to present, like in which way I have to present. The minimum required amount of information should be conveyed. At the same time, you should not also like overemphasize on particular data without any valid reason. These are the things I would like to convey like during all these discussions. So if you calculate the delta value and further the reliability interval, it will be from the previous equations only. The same equations are given here also. Okay. This is to give you an idea for the first part, A part, where the concentration is 2%. You see from 2 to 3, when you are increasing the number of determinations, you can see the improvement is around 16.63%. On the rightmost column, you see when you come from 2 to 3 number of determinations, when you increase one more determination, you are increasing the reliability by 16%. A very good amount of improvement is there, isn't it? When you go from 3 to 4, the increment is less. When you go up to like 5 or 6, you see the improvement is decreased, like marginal only. This is almost similar in trend compared to the T value increment. That means if you are looking for a concentration of 2% of chloride using this particular method, instead of doing 2 measurements, if you do 3, your data quality improves by 16%. Whereas same type of calculation for 20%, another amount, another level, you see, there is that much less improvement in the quality of the data, only 3%. Depending on the level which you are looking for. When you are looking for micro levels, you may have to do number of measurements more and more. So if you want to improve or qualify your data, Focus on that level where there is a scope for improvement rather than for the 20% of chlorine. By increasing the number of measurements, you are not gaining much. So instead of wasting time for number of measurements at 20% chlorine, where you may have to do more and more reagent input also. What you can do is same effort you can apply for the 2% data, 2% of chlorine data. That way you can like manage your experimental time also accordingly. Where to focus so that the same quality can be achieved. Even though the general consensus is that 6 to 7 number of measurements are good enough, but when you are at high concentration level or higher level of your parameter, you can have less number of measurements and get the data. For example, if you are comfortable in maths, towards the exam, you will give less time for maths, whereas whichever subjects say social science you are weak, what you will do? You will try to spend more and more time in social science to improve. There, the improvement rate will be more. Towards the exam, just prior to the exam, few days prior to the exam, you will see that you can gain sufficiently wherever there is scope for improvement. Whereas already you are getting 99 out of 100 in maths, then if the entire day is spent for math for that 1 mark to get full, it will be bit tedious job for you to do. Definitely it will be ideal to reach to that. So that way one can plan the experiment, where to focus, where to improve. Understood? That is the idea I wanted to convey here. So the reliability interval is one quantity which will qualify your result. The in terms of precision, as well as if you mention the confidence level, then definitely it is including the confidence level. That means the probability that true value will be lying in this particular range when you are mentioning confidence level. If confidence level is not mentioned, yes, which one? L is reliability interval in percentage. Yes. X is the actual value. For example, if you are calculating for 2% chlorine, it is X. It is 2. And the same unit as that of the other one. Standard deviation is also in the percentage unit. X is that actual value.
In the L percentage formula,
yes,
we are not getting 22.99%. So how it is possible?
Which one?
In degree of determination, we are getting that.
You are not getting that. That is
Yes,
100 into delta by X. 100 into 45.99. It is not coming to 2. 46 by 2, it will be somewhere around 23. Should be. 46 by 2 is 23. So 45.99 by 2 should be somewhere around 22.9.
In terms of number of experiment is 3 and the value of 0.1272. Okay. When we are dividing
0.1272. 0.1272 into 100 divided by 3.
Why it is not coming down?
Why? Which one?
It's always 2, right?
No, sorry, it is not 3. It is 2. 2%. It is not 3. Sorry. It is 2. In all these on the upper table, there are 2 parts of the table. Now, up in all these one, X is 2. X is 2 for all. And in the lower one, X means the value you have to use for the second last column. X is 2. And for the lower one, X is 20. X is that actual value. That is what, when you are looking for higher concentration, you can even like restrict your number to low. Maybe 1 or 2 experiments you can do, wind up the slot. Then when you go down in that concentration, as far as chemistry is concerned, that means in order to gain confidence, you may have to do, maybe that is where you are in like giving your input. Higher concentration levels are already people have done, explored. And before presenting the data to third party, definitely you will redo the experiments and confirm to yourself This is the one I wanted to show you from the T table. And with degrees of freedom, we have seen that 6 or 7 number of measurements, we were able to get like almost similar data. Whereas when you have higher concentration, even lower number will give you the same result. That is what I wanted to convey. Done? Clear? Till now, initially when we were comparing two data, we were seeing the actual value or the standard deviation of one, standard deviation of the other one. When we were taking the decision between two people, which one is better, the standard deviation, whichever has got lower numerical value, we considered it as a better one. Another term is variance, square of standard deviation. One can compare the variances also. We can take the ratio of variances, and if the ratio of variances are landing up to 1, that means both the variances, it is almost similar to standard deviation only. Another term only, when you take the ratio of variances, we call it as F value. And we can compare their standard deviations, or we can compare their precisions, and make judgment. This is the basis. Prior to doing t-test or result test, one has to see, because variance is the basic property of any natural variable rather than standard deviation. Then your question will be, why then we are talking always about standard deviation? Variance is when we were doing error propagation rule, we had seen that absolute variances are additive. When we did multiplication, we said that relative variances are additive. So everywhere we were using the term variance, but when we were comparing the T table and all, we were using the term standard deviation. Variance is the fundamental property which is getting propagated. Whereas if you compare the units of the quantities, standard deviation holds the same unit as that of the value. So for expressing a quantity, you always keep standard deviation alongside the value. But while doing mathematical operations, you use variance. Okay. So variance is the key point which is getting percolated in all calculations. So prior to doing standard deviation comparison, one has to judge whether I am comparing two students, they are in the same level or not, same class or not. When I am comparing one student with the other one, second standard student should be compared with second standard student. Like that, first we have to compare the variances. They should be comparable. Comparable means, that is the numerical definition of comparability. Within an order of magnitude. Say for example, one variance is 1, another should be less than, like within plus or minus 5, like that, within 10. And if one variance is 50, the other one can be between 11 to 99, like that. These two variances, their ratio should not be more than 10. You can say within an order of magnitude that they should be there. That check is done via the variance ratio test. We call it as F test. Similar to the T and Z test, we had seen that when the two quantities being compared by this particular parameter, if they are identical, then we say that the null hypothesis stands. That means they are comparable. If at all one of them is very large, then we say that the alternative hypothesis is valid. Similar argument holds here also. When the variances are comparable, the null hypothesis, that means the two people, the two persons, or the two equipments, or the two methods being compared are having identical performances as far as the random variations are concerned. If at all one of them is much smaller, then we say that lower one-tailed type of alternative hypothesis is valid. The same type of line of argument as we had seen in the T and Z. Then if at all one is very large compared to the other one, normally when we take the ratio of variances, S1, one variance to the other one. Normally we write a subscript for the variance 1 and 2. And the square stands for variance. Square of standard deviation is variance. Okay. And the one which we take in the numerator, that is given first number. S1 is the one which is taken on the numerator. We take ratio. No? So S1 square by S2 square. That is the general convention right now. The one which has a subscript 1 will be on the numerator. While reading the Z and T table, we had come down in the period, in the table first. Then we went in the case of Z, we had gone right side when we were reading the second decimal for Z. When we were reading the T table, we had come down in degrees of freedom first. Then we had gone right side, right towards with the significance level or confidence level. In the case of this variance ratio, there is a slight change in reading the table. Be careful while reading this table. Numerator we have taken as 1. Numerator, there is a symbol which is similar to V. Now it is nu. Degrees of freedom. Somewhere people write DF or other notation is nu. Greek alphabet nu. Here on that top row, it is written nu 1, and on the top leftmost one, it is written nu 2. 1 corresponds to, nu corresponds to degrees of freedom. Subscript 1 corresponds to, it is on the numerator. Okay. When you are reading this F table, the tabulated values we call as critical values. So F critical for two-sided test. If the significance test is not mentioned regarding whether you have to go for single or double side, it is simply said that you have to go for two-sided test. And certain degree of confidence also will be mentioned. When you go to internet now, you will see different such tables for a singular parameter F. There you can see single-sided, double-sided tables at different levels of degrees, levels of confidence also. This particular one is two-sided F table at 95% confidence level. General consensus is that you go for two-sided test if not mentioned explicitly, and go for 95% confidence level in all the tests, statistical tests. If at all you are very specific, very stringent regarding your conditions, mention that or specify that and go for 99.7%. If at all you are very strict regarding that particular value. Say for example, some heavy metal in water. You want to restrict the value to less than certain level. Then you can increase the confidence level so that you assure that quality is maintained in a better way. If I ask you to read the F value for 5 degrees of freedom, randomly let us try to read 5 degrees of freedom for the denominator and say 10 degrees of freedom for the numerator 5 degree, denominator 10 degree. What will be the value? 4.236. All of you got the same value? Numerator first from left to right, denominator from top to bottom. Okay. Be careful. Left to right first, or top to bottom second. There is a slight difference. In the other two tables, we had come down first, then went right. Numerator 5, denominator 10. Numerator 5, 921.8 wala row. Then it will be 4.236. Na? 4.236. All of you landed up in the same value. Na? See, if at all by mistake you read the other way around, 5 and 10, what will be the value? 5 down and 10 right. So they are drastically different. No? So in the case of F table, actually when you refer to any internet or textbook, they give you in the footnote how to read it. Take time to read the legend of any table or the title or the caption before using it. They mention usually. Go ahead with that one. It may not be the same always. We have seen this type of representation and we have seen key from left to right is the actually in the case of F table, most of the people follow this type of convention only. Numerator from left to right, denominator from top to bottom. This is a general convention, whether it is single-sided or two-sided. Shall we go ahead to do one numerical? As part of an inter-laboratory exercise. A sample of river water was sent to 2 laboratories for phosphate analysis. 1, 2, 3, 4, 5, 6, 8 values are there by 2 different laboratories, A and B. We have to calculate whether there is any significant difference in their precision. We have to calculate first the standard deviation, then squares of the standard deviation, take their ratio, calculate the F value, then compare this F value with that given in the table. Standard deviation all of us can calculate. You have to do the average, then take the difference between this value and the average, sum it up, square it, divide by the average value, take the square root. No, that divide by the number of degrees of freedom, n minus 1, not the average. We will discuss till this topic only, and some 2-3 more slides are there. Let us leave it now. Then towards the end I have given some 2-3 practice problems for you so that you get an idea what we will be like asking in the exam. Other one more test I have given. If you people are comfortable going ahead, I will go ahead and discuss that one. Otherwise we will leave it at this point. Once you have calculated the F value. So till this class, we have learned how to use Z table, T table, and today F table. Once you calculate the F values, all of you can do at hostel, this one. We will spare 5 minutes to just discuss what sort of like questions will be there in the exam. Here, there were 8 values reported by either of the lab. So you have to go for 7 degrees of freedom for numerator and another 7 degrees of freedom for the denominator. So that way you arrive at the critical value of F. Pardon? Table, oh, similar types of tables, whichever is required, will be provided. If not the entire table, maybe some part of the table with the legend. Required legends will be there, and the you have to be careful how to read through that table. T table, Z table, and F table. That is. We had like say how many number of measurements were there? 8, na? 8 on either like for A and B. So degree of freedom is number minus 1, number of measurements minus 1. That is right. For both it is 7. So we have gone 7 points right, 7 points down. Chi-square test, let us leave it. I will not ask any questions on that part. If anybody is interested in learning it, let it be their part of it. Chi-square test. That is just, I will tell you for those who are interested in. If we have certain number of data points, many people are doing the experiment repeatedly. The chances that how many repeated values you get, for a particular value. Say, for example, if I read the Burette value as 45.1, my friend reads it as 45.2. There may be slight variation. So the chances of getting that 45.1 10 times or 20 times, when you are asked to do repeated measurements, say 10 times, what is the probability that you are getting the same value repeatedly? That probability, predicted probability and the actual probability, whether the predicted probability is agreeing with the actual probability or not. That agreement between predicted value, statistics in the initial definition itself, we told that can be used for predictive analysis also. So whether whatever we predict from the behavior of repeated measurements, whether that is agreeing with the actual experimental result or not, that is demonstrated by chi-square. This also has got tables, tabulated chi-square values for certain degrees of freedom. The same rule for degrees of freedom will be number of measurements minus 1. That way chi-square tables also can be read. This part also we haven't discussed. This we will not. If you want to have an idea regarding how the pattern will be, some true or false questions will be there. Whatever statement is there in all these slides, statement may be as such or some slight twist or modification. True or false questions will be there. In addition to that, this type of match the following questions with the degrees of freedom. One particular parameter will be defined. You have to say what is the number of degrees of freedom for that. Standard deviation for four set of four values, then you have 3 degrees of freedom, isn't it? P-value for comparing two means both obtained from 3. This we haven't discussed in detail. If we have two means, each will have which each is obtained from 3 replicate measurements. One may have two standards, 2 degrees of freedom. Other one will have another 2 degrees of freedom. Total it will be 4. Otherwise, n1 plus n2 minus 2. Whatever be the number of measurements you are taking, the sum it up, and what is the input number of input parameters subtracted by 3 plus 3 minus 2. Otherwise, 3 minus 1 plus 3 minus 1. Both will land up in 4. Numerator in the F-test for comparing two variances. Number. Here many information is given. Whatever is required is to find the number degrees of freedom for the numerator, which is derived from 5 measurements. Many data are that I will not ask in the exam. Similar way, I will not give the same questions, but similar pattern will be there in addition to true or false. These ones we have like spend enough time to do. The rounding off, finding the rounded expression, logic behind the rounding off, then the least significant digit or most significant digit in the expression. All these things are familiar to all of you, I hope. If I change the numerical value, we have to use the significant figures rule, then rounding of rules rather here. Propagation value also an example I will show you. And the number of significant figures will be mentioned. For how many number of significant figures you have to do the rounding of. This type of table will be asked to fill completely. You need not have to give elaborate explanation. Do the logic, do apply the logic with minimum terms required. Okay. First digit being dropped. When I say first digit being dropped, there will be single digit, not more than 1 digit. 4 significant figures we are doing the rounding off. I think all of you will be easily able to do all this. When you are doing the rounding off with numbers, only when the dropped digit is 5, you have to think a little bit. If it is beyond 5, it is more than 5, you can round up. If it is less than 5, the dropped digit is less than 5, always keep it unchanged. Yes? No. First digit, when you are doing the rounding off, dropped digit, we have defined it as dropped digit. When I am dropping 5, 2 is by default gone. I am not targeting 2, I am targeting the number of significant figures. Good that you asked this doubt. Last year also, I think people had. Dropped digit, the digit being dropped, that is the first one, first digit. Okay, it is not the place value, it is the digit which is being dropped. Similarly, the third one, 1, 2, 3, 4, 5. 6 will be the digit. First digit being dropped is the digit 6, which is in the 10th place. These slides I will share with you, then you can do once. And similarly, this error propagation, we had done enough examples to do the error propagation. One thing you have to keep in mind when you are doing addition or subtraction or whatever for that matter, mathematical operation, first you have to make the units identical. Then go for the operation. This was the mistake committed by many people last time also. When one parameter was given in meter, another one in centimeter, they simply did the division or multiplication. You have to make the units identical first, then go for whatever operation you are doing. When you take the ratio, it will be an unitless quantity. These are all the things and whatever we have discussed till date. If you have any specific queries, I shall stay back. Otherwise, good luck to all of you. If you want to discuss with me in detail in person, you can come to meet me in Modla's 3rd floor, 267 Hillside. My phone number is there in that, even in this slide also. My mobile number, if anybody wants, chemistry people are having my mobile number also, if you want any further clarification. In office, I am available from morning 8 o'clock to 4:30. Yes. Mod Labs, 3rd floor, 267 Hillside. 267 Hillside. My phone number is there in the first slide. If anybody wants to discuss, you can call me from even from inside and come. You have written, I will close it. अटेंडेंस शीट किसके पास है? अटेंडेंस शीट then if not mentioned, normally the larger value on the if not mentioned.